All right, 1.4. Most of this is easy. I can already tell you the two things that'll be hardest to keep straight, but they're towards the end. If sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. That's one of my favorite sentences in the statistics book, because I imagine something being statistically tortured, like writhing in pain because of what you're doing with those numbers. If you have bad data, you can't derive good conclusions from it, no matter what you do. If you have gathered your data in a bad way so that it's not representative of the general population, then nothing you say after that has any value, because your data's bad. We need to talk about different methods to collect sample data, and some methods are definitely better than others. Of particular importance is the simple random sample. That's ideally what you would want in every sample. It's not always possible, but a simple random sample is the very best kind of sampling, and we'll talk about its definition in just a minute. But almost everything we do the rest of the semester is a word problem that starts, assume you have a simple random sample. That's because simple random sample is best, and it's what we need in order to do what we're going to do on the calculator. All right, statistical methods are driven by the data that we collect. We typically obtain data from two distinct sources, either observational studies or experiments. Observational studies are just where you observe something. You don't intervene in any way. You're not messing with it. You're just sitting down, taking note of what's going on. If I were a police officer interested in knowing what % of drivers come to a complete stop at that intersection of Webb and, not Genesis, I can't think of what it is. What % of drivers come to a complete stop right there? I might just hide in the bushes, make a tally mark every time somebody approaches the sign, and then make a note, did they come to a complete stop or not? I'm not interacting with those folks in any way. I'm just trying to make an observation, and that's an observational study. No attempt to modify the subject. An experimental study is when you apply some treatment and then observe its effects on the subject. What I just described was an observational study, but if I call that my control group, let's see what % of the population stops if I'm hiding in the bushes, but then I come back the next day and stand beside my car with the blue lights flashing. Do you think a different percentage of the population is going to come to a complete stop if I'm sitting there with my lights on? Yes, I'm affecting the outcome of that. I've applied a treatment, my flashing blue lights, so that I can compare the number of people who stop when a police is not around versus the number of people who stop when a policeman is there. That's an experiment. So are these observations or experiments? In a study sponsored by Coca-Cola, 12,500 people were asked what contributes most to their happiness, and 77% said it was their family or partner. Does that sound like an experiment or merely an observation? When we call up these people and say, hey, what contributes most to your happiness? Are we trying to influence their answer in any way? So, don't you love your family? If we said, don't you love your family, then we might be trying to influence them in some way. But if we're just calling and asking and writing down their answer, then we're just making an observation. So that's just an observational study. A study of the effectiveness of echinacea involved 707 cases of upper respiratory tract infections. Children with 337 of the infections were given echinacea, and children with 370 of the infections were given placebos. Is that an observation or an experiment? Yeah, you got half the kids not getting echinacea and half the kids are, and you want to compare those two groups. The echinacea is the treatment, and that's an experiment.